Hello everybody. Today we're going to be talking about data types in Python. Data types are the classification of the data that you are storing. These classifications tell you what operations can be performed on your data. We're going to be looking at the main data types within Python, including numeric, sequence type, set, Boolean, and dictionary. So let's get started actually writing some of this out. And first, let's look at numeric. There are three different types of numeric data types. We have integers, float, and complex numbers. Let's take a look at integers. An integer is basically just a whole number, whether it's positive or negative. So an integer could be a 12, and we can check that by saying type. We'll do an open parentheses and a close parentheses. And if we say the type of 12, it's going to give us an integer. Or if we say a negative 12, that is also an integer. We can also perform basic calculations like minus 12 plus 100, and that'll tell us it is also an integer. So whether it's just a static value or you're performing an operation on it, it's still going to be that data type if those numbers are whole numbers, whether negative or positive. Now let's take this exact one and let's say 12, and we'll do plus 10.25. When we run this, it's no longer going to be a whole number. It'll now be a float. So let's check this. And now this is a float type because it is no longer a whole number. It's now a decimal number. And the last data type within the numeric data type is called complex. Let's copy this right down here. Now, personally, this is not one that I've used almost ever, but it is one just worth noting. So you can do 12 plus, and let's say 3j. And if we do this, it's going to give us a complex. The complex data type is used for imaginary numbers. For me, it's not often used, but if you do use it, j is used as that imaginary number. If you use something like C or any other number, it's going to give you an error. J is the only one that will work with it. Now let's take a look at Boolean values. So we'll say Boolean. The Boolean data type only has two built-in values, either true or false. So let's go right down here and say type true. And when we run this, it'll say bool, which stands for Boolean. We can do the exact same thing with false, and that is also Boolean. And this can be used with something like a comparison operator. So let's say 1 is greater than 5. And let's check this. This is giving us a Boolean because it's telling us whether 1 is greater than 5. Let's bring that right down here. This will give us a false. So it's telling us that 1 is not greater than 5. And just as we got a false, we can say 1 is equal to 1, and this should give us a true. So now let's take a look at our sequence type data types, and that includes strings, lists, and tuples. Let's start off by looking at strings. In Python, strings are arrays of bytes representing Unicode characters. When you're using strings, you put them either in a single quote, a double quote, or a triple quote. I call them apostrophes. It's just what I was raised to call them, but most people who use Python call them quotes. So right here we have a single quote, and that works well. We can do a double quote, and that works also. And as you can see, they are the exact same output. And then we have a triple quote, just like this. And this is called a multi-line. So we can write on multiple lines here. So let's write a nice little poem. So we'll say, the ice cream vanquished my longing for sweets. Upon this diet, I look away. It no longer exists on this day. And then if we run that, it's going to look a little bit weird. It's basically giving us the raw text, which is completely fine, but let's call this a multi-line. And we're going to call this a variable multi-line. And we're going to come down here and say print. And before I run this, I have to make sure that this is ran. So now let's print out our multi-line. And now we have our nice little poem right down here. Now, something to know about these single and double quotes is how they're actually used. So if we use a single quote and we say, I've always wanted to eat a gallon of ice cream, and then we do an apostrophe at the end, obviously something went wrong here. What went wrong is when you use a single quote and then within your text, within your sentence, you have another apostrophe, it's going to give you an error. So what we want to do is whenever we have a quote within it, we need to use a double quote. These double quotes will negate any single quotes that you have within your statement. They won't, however, negate another double quote. So you need to make sure you aren't using double quotes within your sentence. If you want to do something like that, you need to use the triple quotes like we did above. So we can do double, double, and then let's paste this within it. And anything you do within these triple quotes will be completely fine, as long as you don't do triple quotes within your triple quotes. And we'll say this is wrong. So even though it's between these two triple quotes, it doesn't work exactly. Again, you just have to understand how that works. You have to use the proper apostrophes or quotes within your string. And just to check this, we can always say, here's our multi-line. We can always say type of multi-line, and that is still a string. One really important thing to know about strings is that they can be indexed. Indexing means that you can search within it, and that index starts at 0. So let's go ahead and create a variable, and we'll just say a is equal to, and let's do the all popular hello world. Let's run this. And now when we print the string, we can say a, and we're going to do a bracket. And now we can search throughout our string using the index. So all you have to do is do a colon, and we can say 5. What this is going to do is going to say 0, position 0, all the way up to 5, which should give us the whole hello, I believe. Let's run this. And it's giving us the first 5 positions of this string. We can also get rid of the colon and just say something like 5. And then when we run this, it's actually going to give us position 5. So this is 0, 1, 2, 3, 4, and then 5 is the space. Let's do 6 so we can see the actual letter, and that is our W. We can also use a negative when we're indexing through our string. So we could say -3, and it'll give us the L because it's -1, 2, and 3. We can also specify a range if we don't want to use the default of 0. So before we did 0 to 5, and it started at 0 because that was our default, but we could also do 2 to 5. Let's run this. And now we go position 0, 1, and then we start at 2, L, L, O. Now we can also multiply strings, and we have this a hello world. So we can do a times 3. And if we run this, it'll give us hello world 3 times. And we can also do a plus a, and that is hello world, hello world. Now let's go down here and take a look at lists. Lists are really fantastic because they store multiple values. The string was stored as one value, multiple characters, but a list can store multiple separate values. So let's create our very first list. We'll say list really quickly, and then we'll put a bracket, and a bracket means this is going to be a list. There are other ones like a squiggly bracket and a parentheses. These denote that they are different types of data types. The bracket is what makes a list a list. So to keep it super simple, we'll say 1, 2, 3, and we'll run this. And now we have a list that has 3 separate values in it. The comma in our list denotes that they are separate values. And a list is indexed just like a string is indexed. So position 0 is this 1, position 1 is the 2, and position 2 is the 3. Now, when we made this list, we didn't have to use any quotes because these are numbers. But if we wanted to create a list and we wanted to add string values, we have to do it with our quotes. So we'll say quote cookie dough, and then we'll do a comma to separate the value. And then we'll say strawberry, and then we'll do one more, and this will just be chocolate. And when we run this, we have all 3 of these values stored in our list. Now, one of the best things about lists is you can have any data type within them. They don't just have to be numbers or strings. You can basically put anything you want in there. So let's create a new list, and let's say vanilla, and then we'll do 3, and then we'll add a list within a list, and we'll say scoops, comma, spoon, and then we'll get out of that list, and then we'll add another value of true for Boolean. And now we can hit Shift Enter, and we just created a list with several different data types within one list. Now let's take this one list right here with all of our different ice cream flavors. We'll say ice underscore cream is equal to this list. Now, one thing that's really great about lists is that they are changeable. That means we can change the data in here. We can also add and remove items from the list after we've already created it. So let's go and take ice cream, and we'll say ice cream dot append, and this is going to append it to the very end of the list. We'll do an open parentheses, and let's say salted caramel. Now, when we run this and we call it just like this, it's going to take this list, add salted caramel to the end, and we'll print it off. And as you can see, it was added to the list. And just like I said before, let me go down here. We can also change things from this list. So let's say ice cream. And then we need to look at the indexed position. So we're going to say 0, and that's going to be this cookie dough right here. We can say that is equal to, so we can now change that value. So let's call that butter pecan. And now when we call it, we can now see that the cookie dough was changed to butter pecan. Another thing that you saw just a little bit ago is something called a list within a list, basically a nested list. So we had scoops, spoon, true. Let's give this, and we'll say nested underscore list is equal to. Now, when we run this, we now have this nested list. So if we look at the index and we say 0, we'll get vanilla. If we say 2, we'll get scoops and spoons. Now, since we have a list within a list, we can also look at the index of that nested list. So let's now say 1, and that should give us just spoon. And you can go on and on and on with this. You can do lists within lists within lists, and all of them will have indexing that you can call. Now let's go down here and start taking a look at tuples. So a list and a tuple are actually quite similar, but the biggest difference between a list and a tuple is that a tuple is something called immutable. It means it cannot be modified or changed after it's created. So let's go right up here. We're going to say tuple, and let's write our very first tuple. So we'll say tuple underscore scoops is equal to, and then we'll do an open parentheses. Now these open parentheses you've seen if you do like a print statement, but that's different because that's executing a function. This is actually creating a tuple, which is going to store data for us. So we'll say 1, 2, 3, 2, and 1. Let's go ahead and create that tuple, and we can just check the data type really quickly. And it's a tuple. And just like we saw before, a tuple is also indexed. So if we go at the very first position, which is a 1, we will get the output of a 1. But we can't do something like append and then add a value like 3. If we do that, it's going to say tuple object has no attribute append. It's just because you cannot change or add anything to a tuple, just like we were talking about before. Typically, people will use tuples for when data is never going to change. An example for this might be something like a city name, a country, a location, something that won't change. They definitely have their use cases, but I don't think they're as popular as just using a list. So now let's scroll down and start taking a look at sets. But really quickly, let me add a few more cells for us. And let's say sets. Now a set is somewhat similar to a list and a tuple, but they are a little bit different in the fact that they don't have any duplicate elements. Another big difference is that the values within a set cannot be accessed using an index because it doesn't have an index because it's actually unordered. We can still loop through the items in a set with something like a for loop, but we can't access it using the bracket and then accessing its index point. So let's go ahead and create our very first set. So we're going to say daily underscore pints. Then we're going to say equal to, and to create a set, we're going to use these squiggly brackets. I don't know if there's an actual name for those, if I'm being honest. I call them squiggly brackets, and that's what we're going to go with. We're going to put in a 1, a 2, and a 3. So let's go ahead and run this. And let's look at the type. And as you can see, it is a set. Now, when we print this out, it's going to show us 1, a 2, and a 3. And those are all the values within our set. But if we copy this and we'll say daily pints log, this is going to be every single day. Maybe I had different values. Now, when we run this and we do the exact same thing, now when we print this, it's going to have just the unique values within that set. Now, a use case for set, and this is something that I've done in the past, is comparing two separate sets. Maybe you have a list or a tuple and you convert that into a set, and that will narrow it down to its unique values. And then you can compare the unique values of one set to the unique values in another set, and then we can see what's the same and what's different. So let's go down here and let's say wife's underscore daily, and we'll just copy this right here. We'll say is equal to, let's do our squiggly lines. Let's do 1, 2, let's do just random numbers. So now this is my daily log and this is my wife's daily log. And now we can compare these values. So let's go right down here. Let's say print. We'll do my daily logs. And then we'll do this bar right here. And this is going to show us the combined unique values. It's basically like putting them all in one set and then trimming it down to just the unique values. So we'll take wife's daily pints log. And when we run this, we actually need to run this first. When we run this, we should see all the unique values between these two sets. And so as you can see, 0, 1, 2, 3, 4, 5, 6, 7, 24, 31. So these are all the unique values between these two sets. We can also do another one. And instead of this bar, we're going to do this symbol right here, which I believe is called an ampersand. Don't quote me on that. But when we run this, it's going to show what matches. That means which ones show up in both sets. So the only ones that show up in both sets are 1, 2, 3, and 5. We can also do the opposite of that by doing a minus sign. And this is going to show us what doesn't match. And so we have 4, 6, and 31. Now, where is our 24 that was in our wife's daily pints log? It's in this one, but we're subtracting the values on this one. So let's reverse this and we'll say daily pints log, and let's run it. Now those are our other values. So we're taking the values of this and then we're subtracting all the ones that are the same and getting the remaining values. And then for our last one, we can get rid of this and we'll do this symbol right here. And this is going to show if a value is either in one or the other, but not in both. So let's run this. So these values are completely unique only to each of those sets. Now, the very last one that we're going to look at in this video is dictionaries. So let's go right down here. Let's add a few cells and let's say dictionaries. Now I saved dictionary for last because this one is probably the most different out of all the previous data types that we've looked at. Within a data type, we have something called a key value pair. That means when we use a dictionary, it's not like a list where you just have a value, comma, value, comma, value. We have a key that indicates what that value is attributed to. So let's write out a dictionary to see how this looks. We're going to say dictionary underscore cream. And just like a set, we use a squiggly line. But the thing that differentiates it is that in a dictionary, we'll have that key value pair, whereas in a set, each value is just separated by a comma. So let's write name, and this is our key. And then we do a colon, and this is then where we input our value. So we're going to say Alex Freeberg. And then we separate that key value pair by a comma, and now we can do another key value pair. So we'll say weekly intake and a colon. And we'll say 5 pints of ice cream, do a comma, and then we'll do favorite ice creams. And now what we're going to do is we're going to put in here a list. So within this dictionary, we can also add a list. We'll do MCC for mint chocolate chip, and then we'll add chocolate, another one of my favorites. So now we have our very first dictionary. Let's copy this and run it. And let's just look at the type. And as you can see, it says that this is a dictionary. Let's also print it out. Now, if we want to, we can take our dictionary cream and say dot values with an open parentheses. And when we execute this, we'll see all of the values within this dictionary. So here's our values of Alex Freeberg, 5, mint chocolate chip, and chocolate. We can also say keys. And when we run this, all of the keys, the name, weekly intake, and favorite ice creams. And we can also say items. So this key value pair is one item, and this key value pair is another item. Now, one difference between something like a list and a dictionary is how you call the index. But you can't call it by doing something like this, where you just do a bracket, and say 0. So this would, in theory, take this very first one, right? Our very first key value pair. That's going to give us an error. How you call a dictionary is actually by the key. So it doesn't technically have an index, but you can specify what you want to call and take it out. So we're going to say name, and this is going to call that key right here. And when we run this, we'll get the value, which is Alex Freeberg. One other thing that you can do is you can also update information in a dictionary, which we can't with some other data types. So for this, for the name, it was Alex Freeberg. Now let's say Christine Freeberg. And when we update that, I'm also going to print the dictionary, get rid of this. So it's going to update Christine Freeberg in that value of the name. So let's go ahead and run this. And now it changed the name from Alex Freeberg to Christine Freeberg. We can also update all of these values at one time. So let's copy this. And I'm going to put it right down here. I'm going to say dictionary.cream.update. Then we're going to put a bracket, or not a bracket, but a parentheses around these. So now what we're going to do is update this entire thing. Let me take this, say print this dictionary. Now we can update this to anything we want. So instead of here, I can say, I'll say weight. And because of all that ice cream, I now weigh 300 pounds. So let's run this. And as you can see, it did not delete our key value pair right here. Instead, it just added to it. When you're using the update, we can't actually delete. That's the delete statement, and I'll show you that in just a second. But all we did was added this new value. It also is going to check and see if you changed anything with your key value pair. So we can go in here and change this value, and we'll say 10. So now when we run this, the value of this key value pair was changed. But let's say we do want to delete it. We'll say DEL, that stands for delete, part of this dictionary cream. And now let's specify the key, which will also delete the value with it. Well, let's specify the key that we want to get rid of. And let's say weight. And then let's print that again. And as you can see, the weight was deleted from that dictionary. So that is all we're going to cover in this data types video. Thank you guys so much for watching. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll